You don't usually expect the universe to surprise you. Not at this age. Not after everything you've seen, read, and watched about the sky. But on one quiet night, when 3-Eye Atlas finally emerged from behind the sun after 35 days of total blackout, something appeared on a telescope feed that shouldn't have been possible. Atlas was off. Not by a lot. Not enough for the average person to notice, but enough for astronomers to freeze in place, staring at a single line of numbers that refused to behave. A shift of a fraction of a degree. A deviation so small you could miss it with a blink. But in deep space, a deviation that tiny can send an object millions of miles away from where it's supposed to be. And this time, it didn't send Atlas away from anything. It sent it towards something. The first person who saw the misalignment ran the calculation twice, then 3 times, then asked someone else to check the software. When the numbers didn't change, the room fell into that strange kind of silence you only get when something is wrong in a beautiful way. Because Atlas hadn't wandered off the predicted path. It had shifted into a new one, a path that extended forward into a razor-thin thread of space more than 500 million miles away. Jupiter's keyhole. You picture the solar system like a map you've seen 100 times. But the keyhole isn't on any map. It's an invisible boundary at the edge of Jupiter's gravitational domain, a region so narrow compared to the vastness of space that hitting it by chance is almost impossible. Statistically, the odds hover around 1 in 26,000. It's the kind of target you only hit with extraordinary luck or extraordinary precision. Most comets wobble, sputter, spin, drift. Outgassing kicks them sideways. Uneven lighting from the sun pushes them unpredictably. But Atlas didn't wobble. It didn't stumble. It slid onto a perfect line, as if guided by a force that knew exactly where Jupiter's unseen border lay. You imagine astronomers leaning closer to the monitors as the new trajectory arc unfolded. A clean, elegant curve slicing directly toward a region no interstellar object has ever approached with this kind of accuracy. A region that pulls only a select few objects inward, while letting everything else drift by. And this visitor from another star was heading right for it. The thought settles into your mind with a calm weight, not frightening, not dramatic, just strange. Strange in a way that doesn't raise your pulse, but sharpens your curiosity. Strange in a way that feels less like chaos and more like intent, even though no one is claiming intent. Not yet. You find yourself wondering about those 35 days Atlas spent hidden behind the sun, a blind spot created by glare, solar radiation, and orbital geometry. The perfect place for a small, quiet force to act. A small push, a tiny release of gas, a subtle shift you would never detect in real time. A moment where something could have changed its journey, and no one on Earth would know until it emerged again. When the dot reappeared, too clean, too aligned, scientists didn't panic. They didn't notify agencies. They didn't draft emergency plans. They just watched, because nothing about Atlas suggested danger. Nothing pointed toward Earth. Nothing indicated a threat. The unsettling part wasn't where it was going. It was how perfectly it was going there. You take a breath, settling deeper into whatever you're sitting or lying on. You feel the same pull that those astronomers must have felt. A quiet fascination. A need to understand how an object from another star could glide so effortlessly into a gravitational doorway millions of miles wide, yet mathematically tiny on the cosmic scale. And you feel something else too. Something you don't often admit out loud. That small, electric thrill that only space can give you. The sense that you are witnessing the beginning of a mystery, one that unfolds slowly, gently, like a ripple across dark water. Tonight, you're not here for drama. You're here for the kind of story that lets your mind wander while your body relaxes. A story about precision, probability, and a visitor moving through your solar system with a grace that defies explanation. A story that starts with a shift so small it barely registers and leads to a destination so specific it becomes impossible to ignore. So, settle in, slow your breathing, let your eyes grow heavy if they want to, and follow this thin line with me, the one that starts with a misaligned dot on a quiet telescope feed and ends at one of the most mysterious places Jupiter has to offer. By now, you know the basic outline. Atlas went behind the sun, disappeared for 35 days, and came back on a path that didn't quite match the prediction. But to really understand why that tiny mismatch matters, you have to look at where that new path leads, not just toward Jupiter, but toward something wrapped around it that you can't see. If you could switch off the colors, the storms, the bands of cloud, and look at Jupiter only through the way it bends space, you'd see a different picture. You'd see a massive dent, a deep bowl pressed into the fabric of the solar system. The sun makes the biggest depression, of course, but Jupiter carves its own. It doesn't just orbit the sun. It drags the space around it down like a giant invisible weight on a rubber sheet. That bowl has a reach. It extends outward into a huge region called the Hill Sphere, a zone where Jupiter's gravity starts to compete with the sun's. On paper, that sphere stretches roughly 52 million kilometers from side to side. In your mind, you can think of it as an enormous, transparent bubble hanging in space around the giant planet. Outside the bubble, the sun is still in charge. Inside it, Jupiter starts to make the rules. Now picture yourself drifting toward that bubble. Far away, you hardly feel anything. The sun is still the main pull. But step by step, kilometer by kilometer, Jupiter's tug grows. It's like walking toward the edge of a hill. At first, the slope is gentle, almost flat. Then it starts to steepen. Go a little too far, and suddenly you're being pulled downward faster than you realized. Cross the boundary, and you're in Jupiter's world now, not the sun's. You don't orbit the star anymore. You orbit the giant. That boundary, that thin region where the balance tips from Sun to Jupiter, is where the story of Atlas becomes something more than just a curious orbit. Because the Hill Sphere isn't a simple on-off switch. There's a razor-thin shell near its edge where the gravitational forces nearly cancel, a fragile balance between two massive bodies. Think of it like the edge of a keyhole. If you approach at just the right angle, you skim along that edge. Too high or too low, and you miss the opening completely. You either stay with the sun or fall deeper into Jupiter's grip. There isn't much room for error. And yet, that is exactly the region Atlas is headed toward. When astronomers extended the new trajectory, they realized that Atlas isn't just passing in Jupiter's neighborhood. It is projected to skim the Hill Sphere at a distance of about 60,000 kilometers from the mathematical boundary. 60,000 kilometers out of 52 million. On that scale, it's like standing in one city and throwing a dart that hits the button on someone's coat 3 states away. You don't do that by accident very often. In fact, when teams at JPL and ESA ran the numbers, the odds came out around 1 in 26,000. One chance in 26,000 for a random, unsteered interstellar visitor to happen to graze this specific shell, at this specific distance, at this specific angle. You don't stumble into Jupiter's keyhole. You arrive there. That's the part that lingers in your thoughts as you listen. Comets and icy bodies are supposed to be messy. They vent gas unevenly. They spin oddly. They get kicked around by sunlight and thermal stress and the uneven way their ices heat and crack. All of that chaos usually smears out their trajectories, making them wobble and wander. Nature is noisy. Nature doesn't usually draw straight lines. Atlas just did. Some outgassing could, in theory, nudge a comet closer to such a region. A jet of vapor here, a burst of gas there. But those jets aren't deliberate. They don't aim. Most of the time, they push objects away from delicate alignments, not toward them. Yet the best fit solution for Atlas, after it emerged from behind the sun, is a path that threads this narrow gravitational edge almost perfectly. That's why the odds matter. Not because 1 in 26,000 is magical on its own, but because it describes how rarely a path like this should appear without something very specific shaping it. Random trajectories don't just graze Hill spheres. Kelly Fast said that about a different object in a different context, but the sentence fits Atlas like a glove. It's the kind of line that sticks with you. A reminder that precision, especially quiet precision, is suspicious in the most scientific sense of the word. And yet, even as you let that sink in, there's no reason to feel alarm. Jupiter is still more than 600 million kilometers away. The keyhole is not a gateway to disaster. Atlas is not on a collision course with Earth. It's not threatening your night, your home, or your life in any practical way. If anything, what's happening out there is so far away that you will never notice it, except as a line on a plot and a faint whisper in a telescope's archive. The unease here is not about danger. It's about design, or something that looks like it. You lie back a little more, feeling the pillow, the couch, the chair beneath you, while your mind floats somewhere near Jupiter, tracing the invisible skin of that gravity bubble. You imagine this strange, dark object from another star skimming that edge, moving along a path carved out not by brute force, but by the subtle arithmetic of the cosmos. And you're left with a simple, quiet question. How did it get onto that line? Because trajectories like this don't appear for free. They are born from forces, from pushes and pulls, from tiny changes applied at just the right time. Something nudged Atlas into this new course. Something small, something timed, something that happened when no one on Earth could see it. But this precision didn't come from nowhere. Something happened when Atlas was hidden behind the sun. For 35 days, the sky went silent. Not because anything dramatic happened, not because Atlas vanished into danger, but because it passed behind the sun from our point of view, a period astronomers call solar conjunction. During that window, the sun's glare overwhelms every instrument we have. Telescopes saturate. cameras drown in light. Sensors pick up nothing but noise, and Atlas moved through that blinding zone, invisible to us, like a ship slipping behind a lighthouse beam. It was a month-long blackout. You can imagine the feeling at the observatories, watching the last reliable coordinates fade into the glare, doing the math, marking where the object should reappear when it comes out the other side. The models were clear. Gravity is predictable. If nothing strange happened, Atlas would return exactly where the equations said it would. No surprises. But when it reappeared, something was wrong. Not wrong in a dramatic way. Wrong in the way a single millimeter is wrong on a ruler. Wrong in the way a compass needle wavers for one heartbeat before settling. The point of light showed up just slightly off the predicted track. You'd never see it with your eye. But the software saw it instantly, and the numbers didn't match the expectation. The first reaction was simple. Run the simulation again. Then again. Then again, with a different ephemeris. But the offset held steady. The equations only lined up when astronomers added something new. A tiny, almost imperceptible acceleration acting on Atlas during the blackout. A push. So small, it might as well not exist. So subtle, it would never show up in a single frame. But stretch that force across 30 days of darkness, and suddenly you get a trajectory shift just big enough to matter. This is what astronomers call non-gravitational acceleration. Most of the time, it comes from outgassing. Jets of vapor shooting off a comet's surface as the sun heats it. It happens constantly in the outer solar system. Icy bodies hiss and whisper and spit tiny bursts of gas into space. But those bursts are chaotic. They push objects randomly in unpredictable directions, often throwing them slightly off course. The acceleration inferred for Atlas was measured at roughly 5 × 10 to the -7 AU per day squared. A number so microscopic it barely fits inside your imagination. But the direction of that acceleration, that was the strange part. It pointed not into randomness, but into alignment. It nudged Atlas closer to Jupiter's keyhole, as though the push had been placed exactly where it needed to be. A breath on a billiard ball. That's all it would take. One soft exhale, one tiny disturbance, and suddenly, the whole table changes. A whisper that alters the entire path. You breathe slowly as you picture it. Atlas, drifting behind the sun, out of sight, untouched by our instruments. A silent place where a tiny jet of gas could have fired, or a crack could have opened, or something unknown could have acted. You imagine that invisible moment, the darkness, the heat, the isolation. And in that darkness, something pushed. Just once. Just enough. But here's the problem. Natural outgassing doesn't behave like this. When comets vent gas, they spray in all directions. They tumble. They wobble. They drift unpredictably. They do not produce acceleration vectors that are clean, efficient, or lucky. They certainly don't produce pushes that land objects on 1 in 26,000 trajectories toward gravitational keyholes. Yet Atlas did. That's why astronomers paused. Not because they were afraid, but because the data didn't follow the usual pattern. When a natural object experiences non-gravitational acceleration, it often behaves like a kicked pebble, jittery, messy, uneven. Atlas behaved like something nudged with precision. Outgassing never does this, not this clean. Marco Micheli said that years ago, analyzing another interstellar object. But tonight, the sentiment feels like it belongs to Atlas. Natural processes don't aim, they don't guide, they don't optimize, and they don't push in exactly the direction needed to skim the edge of Jupiter's Hill sphere with almost surgical accuracy. You feel the air settle around you as the thought takes shape. This doesn't imply control. Nothing here suggests a steering mechanism or a guiding hand. But it does hint at something more intriguing: intention, or at least something that behaves surprisingly like it. A force too small to notice, yet too perfect to ignore. You let your breathing slow. Your shoulders loosen. The room grows softer, quieter. The mystery remains, but the tone eases, as though the universe is reminding you that curiosity is safe and wonder is welcome. Whatever happened behind the sun didn't threaten anything. It simply shaped a path now leading toward the most delicate gravitational threshold Jupiter offers. And somewhere in that 35-day blackout, the trajectory shifted. A tiny push in the dark, a whisper of acceleration, a change no one saw, yet everyone can measure now. So what happens when a tiny push becomes a perfect trajectory? Imagine standing on the edge of New York City with a paper airplane in your hand. You fold it carefully, smooth the creases, lift it into the wind, and let it go. Now, imagine that simple sheet of paper gliding all the way across the country, crossing mountains and deserts and empty plains, never drifting off course, never stalling, never wobbling in the breeze, and landing gently on a single rooftop in Los Angeles. That is the scale of precision you're dealing with when you talk about an interstellar object hitting a gravitational keyhole near Jupiter. Space isn't forgiving. A tiny wobble becomes a massive deviation. A small drift multiplies over millions of kilometers, and yet Atlas is gliding along its line as if space itself had cleared a path for it. To understand why this is so unusual, you have to imagine its motion not just in 3 dimensions, but in 6, a full 6D trajectory. 3 numbers describe its position: x, y, z. 3 more describe its velocity: vx, ve, v's. These 6 values act like coordinates on a map the universe uses to guide an object along its path. If even one of them drifts, even slightly, the journey changes. A tiny shift in velocity today becomes a massive displacement a year from now. A microscopic deviation in position becomes a huge miss hundreds of millions of kilometers later. Even a tiny drift in one of these 6 numbers sends you millions of kilometers away later. But here's the strange part. Every deviation we've measured in Atlas's motion, every minor shift, every tiny correction, all of them lean in the same direction. The direction that moves it closer to Jupiter's Hill sphere. There's no sign of the usual chaos. No random jets. No scatter. No noise. Instead, its course looks smooth, clean, almost disciplined. This isn't what comets do. Most comets behave like half-frozen fireworks. They spin unpredictably. They release gas in chaotic bursts. They heat unevenly. They respond to sunlight with irregular kicks and sideways shoves. Their trajectories jitter and wander naturally, like leaves caught in a stream that flows over stones and eddies. You expect turbulence. You expect noise. But Atlas isn't noisy. It's steady. Its line doesn't look like it's being kicked by random jets. It looks like it's being guided by a remarkably tidy sequence of physical effects, or by something that imitates tidiness with eerie accuracy. It's a leaf floating downstream and landing exactly on a particular stone. And that's the part that feels strange in your chest when you think about it. The universe loves chaos. It thrives on randomness. It rarely draws straight lines unless gravity forces it to. And in Atlas's case, gravity didn't force this. Something else did. You picture its long journey, moving through millions of kilometers of emptiness, through radiation from the sun, through the shifting gravitational pull of planets, through temperature changes that should make its surface crack and hiss and vent in random ways. Each of these should introduce noise into its motion, tiny disruptions that scatter the object's path over time. But Atlas has been moving like a bead on a wire. At distances measured in hundreds of millions of kilometers, even the smallest force normally becomes a large deviation, a jet of vapor, a patch of sunlight warming one side, a micro-outburst caused by a tiny fracture. All of these should push Atlas off track, just enough to matter. And yet, the object remains aligned. The stream it follows has not wavered significantly at all. That's why astronomers keep raising their eyebrows at the data. It's not because the force is large. It's because the lack of chaos is large. This is the part that catches your breath a little. Atlas's mystery isn't about power. It's about cleanliness, about order where disorder should exist, about steadiness where noise should dominate. Natural objects don't maintain this kind of precision over long distances. They don't retain narrow, well-shaped trajectories after spending weeks behind the sun. And they don't glide toward a gravitational feature as thin as Jupiter's keyhole unless some sequence of forces, is helping them. Avi Loeb once wrote, "Precision is the signature of intention." You don't have to accept that fully to feel the weight of it. You don't need to assume control or technology or purpose. You only need to accept that rare behavior deserves rare attention. And that is what you feel now. Attention sharpening, not in fear, but in curiosity. Because the further you look into Atlas's path, the more it resembles something gently guided, not steered, not controlled, not pushed by anything exotic, just shaped. Shaped in a way that avoids the chaotic fingerprints of natural outgassing. Shaped in a way that gives you pause. Shaped in a way that whispers instead of shouts. You settle deeper into your seat or your bed, letting the tone soften. Whether this is coincidence or design, the motion is undeniably graceful. It doesn't demand alarm. It doesn't shout for interpretation. It simply asks you to watch. And watching it is enough. Because the quietness of the path, the steady, unwavering line, is what makes it strange. A tiny nudge shouldn't become a perfect trajectory, yet here we are. A force too small to see, guiding a line too perfect to dismiss. You breathe slowly, letting the curiosity settle like dust in a beam of light. There is no need for urgency, no need for alarm, just a deepening sense that you are standing at the edge of a cosmic puzzle, one that unfolds not through drama, but through subtlety. And after all this precision, one question rises naturally. But if this trajectory is so precise, why aim it at Jupiter? If you could switch off every light in the solar system, the planets, the moons, the glow of reflected sunlight, and leave only the pull of gravity behind, you'd see a landscape unlike anything on Earth. The map would look like rolling hills and deep valleys made not of rock, but of force. And rising above everything else, glowing like a massive mountain made of invisible weight, would be Jupiter. If gravity could glow, Jupiter would be the brightest mountain in the solar system. Its influence is staggering. Jupiter carries more than 300 times the mass of Earth. It outweighs every other planet combined. It bends space so powerfully that asteroids pile up around it like debris caught behind a boulder in a river. Thousands of objects, rocks, ice, captured fragments, have their orbits sculpted by this one giant. Its hill sphere, the region where its gravity competes with the sun's, spans more than 50 million kilometers. That's a gravitational kingdom, larger than anything else that orbits our star. And that kingdom is surrounded by a world of worlds. Jupiter doesn't travel alone. It carries at least 79 moons, each one with its own story. Europa, with an ocean hidden beneath its frozen shell. A global sea, deep and dark, warmed from below. Ganymede, so massive it creates its own magnetic field, the only moon known to do so. Io, spewing lava into space, the most volcanic place in the solar system. Callisto, ancient and cratered, frozen in time like a preserved memory of the early universe. Stand far enough away, and you see Jupiter, not as a planet, but as a system, a miniature version of a solar system, orbiting within the larger one we call home. And that system is valuable. If you were exploring the solar system, not as a tourist, but with purpose, Jupiter would be a strategic paradise. Its moons contain ice, rock, metals, and chemistry in forms you don't find anywhere else. Its magnetic field is so strong, it creates a natural shield, protecting anything inside from radiation that would roast other objects. And then there are the Trojan asteroids, two massive swarms of stable gravitational islands that trail and lead Jupiter in its orbit, perfect ambush points or hiding spots for anything that wants to stay unnoticed. If you wanted to disappear in this solar system, you wouldn't hide near Earth. Earth is loud. Earth is watched. Earth is wrapped in radar, satellites, telescopes, radio networks. Earth is a house surrounded by bright windows, noise, and neighbors who never sleep. But Jupiter is quiet. It sits far away in the cold, on the edge of the solar system's inner domain, turning slowly like a silent guardian. We visit it with probes once every few decades. We image it occasionally, but we don't watch it constantly. We don't monitor its surroundings the way we monitor Earth's. Jupiter is a gigantic, silent fortress where very few of our eyes are pointed on any given night. You don't camp next to the noisy neighbor. You camp a few houses away, and that's what makes Atlas's trajectory unsettling in the most scientific way. Not frightening, not alarming, just strange. If there were ever a place in the solar system where something could study, observe, or rest without drawing attention, it would be in Jupiter's shadow. Not near Earth, not near Mars. Near the giant that bends space so deeply it creates pockets of stability in the swirl of cosmic motion. This doesn't mean intention. It doesn't imply purpose. But it does mean that, of all the places an interstellar object could approach, Jupiter happens to be one of the most strategically meaningful. Especially if you want to understand the architecture of the solar system without being seen. Michio Kaku once said, "If you want to control the solar system, you start with Jupiter." He meant it figuratively, scientifically, but the principle holds. Jupiter is the center of gravity politics in this planetary family. Its pull shapes migration patterns. Its location anchors orbits. Its mass dominates every long-term dynamical model we have. It is not just a planet. It is the solar system's anchor. You breathe slowly as you picture it. A giant made of gas and storms, spinning with a calm violence, standing at the far edge of the night like a massive ancient sentinel. If planets had personalities, Jupiter would be the quiet one. The giant who doesn't move much, but whose presence changes everything around it. A giant so large that the rest of the solar system dances to its rhythm, whether it realizes it or not. And now you picture a thin line, Atlas's trajectory, stretching toward that giant, not toward Earth, not toward Mars, toward Jupiter, the place that almost no one watches carefully, the place built for permanence, the place where objects can hide in the gravity wells or linger in Trojan swarms for centuries, even millennia. If Atlas is heading toward Jupiter, it's heading toward a place built for permanence. You let the idea settle gently, like dust drifting through a sunbeam. The mystery doesn't need intensity to be compelling. It just needs scale. And Jupiter provides that scale in a way nothing else in our planetary neighborhood can match. A gravitational fortress, a quiet mountain, a place where trajectories mean something more than simple paths through space. And right now, our only witness near Jupiter is already waiting. Far from Earth, in a cold, quiet orbit around Jupiter, a small spacecraft glides through the darkness like a patient sentinel. It isn't large. It isn't fast. It doesn't glow or roar or sweep the sky with beams of light. It simply circles the giant planet every 53 days, powered only by sunlight that arrives thin and weak that far from the sun. It has been circling the giant for years, listening more than looking. That spacecraft is Juno. And for the story of Atlas, it may be the only witness we have. You imagine it now, drifting above Jupiter's cloud tops, a silent shape of solar panels and instruments slicing through the emptiness. When the spacecraft was launched, no one imagined it would one day be positioned near the arrival point of an interstellar visitor. Juno was built to study the atmosphere, the magnetic field, the auroras. It wasn't built to play lookout for objects from beyond the solar system. And yet somehow, it's the only human-made eye waiting at Jupiter's side as Atlas approaches. You picture its orbit as a long ellipse, diving close to the clouds and then swinging far out again, a looping rhythm repeating every 53 days. With each pass, Juno gathers information. Radio waves, magnetic signatures, thermal patterns, particle counts. The spacecraft is not always looking outward, but it is always listening. And what it carries on board makes it more capable than it first appears. There is JunoCam, a visible light camera that sends back images of storms and cloud belts. Beautiful, soft, familiar pictures, but also sharp enough to capture a tiny moving point if it crosses the frame at the right time. There is GYRAM, an infrared mapper that reads heat like a new kind of vision, able to reveal hidden structures and warm objects even in the deepest cold. If something near Jupiter releases heat or reflects just enough sunlight, GYRAM might see it. Then there is WAVES, an instrument that listens to radio emissions and plasma patterns, mapping the invisible environment around Jupiter. If a signal appears that doesn't match anything local, anything natural, anything expected, waves would be the first to hear it. Juno also carries particle detectors, Jade and Jedi. These instruments track high-energy ions and electrons, scanning for unusual spikes or flows that hint at something passing through. Taken together, these tools form a quiet but capable observatory, one that might detect a flash from a metallic surface, or a radio whisper drifting through the plasma, or a faint infrared glow where none should exist. Or Juno might detect nothing at all. That possibility is just as important. In science, silence is still data. If Juno sees nothing, no glint, no heat patch, no unusual signal, then Atlas is behaving like a natural object. It means the tiny push behind the sun was likely caused by outgassing or another benign effect. It means the elegance of the trajectory was only coincidence, not a pattern. Even emptiness can be reassuring. But the possibility remains that Juno could detect something subtle, a small dot moving against the background stars, traveling just a little too steadily, a flicker of warmth at a wavelength that puzzles the algorithms, a burst of radio energy that doesn't match Jupiter's usual symphony. Most likely, Juno will see nothing unusual, and that's okay. But if it does see something, it will be the first time a human-made eye has watched a visitor from another star arrive at a new world. You follow that thought slowly, letting it settle. For all our telescopes and satellites and deep space eyes, nearly all of them are pointed elsewhere. Earth watches Earth. Mars is observed constantly. The inner planets are crowded with instruments. But Jupiter? Jupiter stands alone, monitored only in glimpses, visited only on long timescales. And Juno, with its slow, looping orbit, is the closest thing we have to a guardian, a scout, a lone reporter taking notes in the dark. The timing is remarkable. By March 2026, Juno will swing through a part of its orbit that aligns almost perfectly with the region where Atlas is projected to pass. Not right through the same spot, not close enough for risk, but close enough to watch, close enough to record something without even trying. The spacecraft will be there because that is simply where math and timing place it. A coincidence, or something that feels like coincidence, lining up with quiet precision. You can almost feel the anticipation. Not sharp, not anxious, soft, like waiting for a distant echo. The sense that something might happen or might not, but either way, a story will be written. Juno wasn't designed to hunt for visitors. It wasn't built to scan for extraterrestrial probes or track interstellar debris. But sometimes, the universe arranges things in ways you couldn't plan if you tried. Juno was never designed for this, but it might be the spacecraft that tells the story. Heidi Becker once said that about Juno's resilience to radiation, but tonight the line seems to fit this moment too. Juno may become the first spacecraft to witness what happens when an interstellar object approaches a giant world. You shift gently, relaxing more fully into the quiet around you. The story doesn't feel heavy. It feels steady, calm. You're not waiting for danger. You're waiting for understanding, the kind that comes slowly, softly, one data point at a time. Whether Jupiter reveals something or reveals nothing, the mystery deepens. Because something is moving toward the giant. Something that glided along a line too clean to ignore. And now, a small, lonely spacecraft waits in the cold to greet it. But what if Atlas isn't just drifting toward Jupiter, but preparing for something? Picture a cathedral of ice drifting between the stars. Not built with stone or steel, but carved from frozen water, dust, and ancient carbon. Light glints off its surface like stained glass. Shadows pool in its cracks. And around it, the cold of interstellar space presses in from every direction. From a distance, you would never guess what it is. You would only see an object that looks exactly like a comet, a familiar traveler, wrapped in the same kind of frozen shell that billions of comets wear. But a shell can hide things. And a cathedral can be more than a place of worship. It can be a vessel. A comet's outer layer is one of the best forms of cosmic camouflage. Its thick crust protects against radiation. Its dark, carbon-rich skin absorbs stray signals. And when heated by a star, it releases jets of gas. Jets that look completely natural, even if something inside is guiding them. To any distant observer, everything appears ordinary. A dusty, icy body releasing vapor as it approaches the sun. But if you wanted to conceal a craft, a mothership, drifting through a civilization that isn't ready to see it, you couldn't ask for a better disguise. The idea isn't new. Scientists have quietly debated versions of this possibility ever since Oumuamua passed through the solar system in 2017. It moved without a tail, reflected light strangely, and accelerated away from the sun with a kind of gentle, non-gravitational push. Avi Loeb suggested that it might have been a light sail, a thin, engineered structure gliding on sunlight. Atlas, though, is different. Where Oumuamua was a dry, tumbling shard, Atlas behaves like a hybrid, part natural comet, part something else. It has a coma, a tail, and outgassing. But wrapped inside, all that is a trajectory too clean to dismiss, a line too elegant to ignore, something that almost hints at intention, even if the intention is quiet. So how could something inside a comet move across interstellar space? There are a few possible technologies, not fantastical, not magical, but grounded in physics we already understand. One is a solar sail. Imagine a thin sheet the size of a stadium, pushed gently by sunlight. Over long distances, that whisper of pressure becomes powerful. A solar sail could cross light years if given enough time. Another is a magnetic sail. Instead of capturing photons, it catches charged particles. The plasma streaming from stars. A giant magnetic field could slow a craft as it enters a new system, or steer it without leaving any visible trace. And then there is beamed propulsion, a system where a remote laser somewhere far away pushes a craft forward early in its journey. Once it reaches speed, the craft drifts silently for centuries. No engine needed, no plume, no signature. These technologies don't shout, they whisper. And whispering fits what Atlas seems to be doing. Because a craft that wants to travel unnoticed wouldn't need a roaring engine. It would only need a few precise nudges, just enough to adjust a trajectory, just enough to slide toward a keyhole near Jupiter, just enough to shift by a fraction of a degree. The kind of push we saw during Atlas's blackout behind the sun. You don't cross the stars with loud thrust. You cross them with patience. Inside that frozen shell, imagine a long sleeping machine. Maybe it launched thousands of years ago, maybe hundreds of thousands. It doesn't need crew. It doesn't need warmth or comfort. It only needs durability. The ability to shut down nearly everything, to rest and to wake when triggered by a star's light, or a timer, or something we can't imagine. A mothership doesn't need to be alive in the way we think of life. It only needs to endure. And a comet is perfect for endurance. A thick, icy skin protects whatever lies inside. A coating of dust hides sharp edges or reflective surfaces. Outgassing masks small maneuvers. Natural processes become camouflage. The galaxy becomes your ocean, and you drift quietly through it, carried by gravity and time. There's nothing dangerous implied here, nothing alarming. This isn't a story about threat. It's a story about possibility. The gentle kind that expands your thinking without tightening your chest. Because even if Atlas is not a craft, even if it is entirely natural, its behavior resonates with the logic of long-distance travel. Clean trajectories, small nudges that create large effects, quiet motion, silent patience. A mothership wouldn't need to arrive loudly. It wouldn't need to reveal itself. If it had a mission, surveying, mapping, studying, seeding signals, or simply drifting, it could complete that mission without ever being noticed. And that leads to a gentle question that drifts through your mind like a soft breeze. If you wanted to move silently through a young civilization's sky, wouldn't you wear the skin of a comet? You can feel the shift in your breathing as the idea settles. Not frightening, not wild, just calmly strange. Something about the image holds you for a moment. A cathedral of ice drifting through a cold universe, carrying something that sleeps until it needs to wake. Maybe Atlas is only a comet. Maybe it's something more. Both ideas are part of the same cosmic wonder. And there is one more piece to consider. Timing. Why now? Why 2025? Why this part of Jupiter's orbit? Why this chapter in our civilization's story? If Atlas is simply drifting, we are witnessing coincidence. If it is carrying something, then time itself becomes part of the design. Nothing here says danger, only design, or something that looks very much like it. A quiet presence moving through a quiet system, wrapped in frozen camouflage that would fool almost any observer. And if it truly is a messenger, then the next question becomes unavoidable. But if Atlas is a messenger, why deliver it in 2025? In the universe, timing is everything. Most visitors from interstellar space wander in at completely random moments, quiet centuries, uneventful decades, times when no one is paying attention. They don't choose a season. They don't choose a year. They simply arrive when gravity delivers them. But 3I Atlas didn't arrive at a quiet moment. It appeared in our sky during one of the loudest, brightest, most turbulent chapters in the life of our star, the solar maximum. That's the part that makes you pause. Solar maximum is when the sun becomes restless, not dramatically, but energetically. Its surface seethes with magnetic knots. Its corona crackles. It releases flares that carry X-rays across the solar system, and coronal mass ejections that send clouds of charged particles flying outward like invisible storms. These storms interfere with everything we use to watch the sky. Radio telescopes, radar systems, spacecraft receivers, even Earth's magnetic field. During solar maximum, the universe becomes noisy. Signals blur. Data fuzzes. Instruments saturate. and the deep sky becomes harder to parse because the sun is shouting over everything. That is the exact moment Atlas entered, and then came the 35-day blackout, a solar conjunction already guaranteed to blind our instruments, stacked on top of the most turbulent phase of the sun's cycle. Solar conjunction plus solar maximum, a double blind spot. If something wanted to move, to adjust, to deploy, or simply to pass unnoticed, there would be no better time. But timing is not just about the sun. It's also about us. Humanity is louder in space than ever before. Our planet is covered in satellites. Our skies hum with communication bursts, navigation signals, radar sweeps, digital echoes of our technology expanding upward. And now, as we enter the late 2020s, we're stepping into what many scientists call the second space age. Between 2025 and 2030, Earth becomes dramatically different from the Earth of the past. Artemis returns humans to the moon. Starship begins to redefine launch capabilities. Mars sample return missions prepare to bring ancient dust home. Private companies send constellations of satellites into orbit. Space telescopes multiply. Deep space tracking improves. Our radio noise spreads further and further into the cosmic dark. For the first time, we are not just a species on a planet. We are a species reaching outward, a civilization watching its own sky more closely than any generation before. If you were observing Earth from far away, quietly, patiently, you might wait for a moment when the civilization becomes interesting. When it grows, expands, begins to touch its own cosmic neighborhood. You would wait for an observability window, a moment when the signals from that world become rich enough to study. And 2025 is exactly when that window opens. Not too early, when our skies were dark and quiet. Not too late, when our sensors will be too powerful to miss anything. But right now, when humanity is just visible enough to be worth watching, but not yet aware enough to understand what it's seeing. Like a fisherman waiting for the tide, Atlas arrived when the waters were just right. You take a slow breath, absorbing the idea. It doesn't feel dramatic. It doesn't feel alarming. It feels aligned, a quiet coincidence with edges that feel too smooth to ignore. A cosmic timing that might be random, but doesn't feel random. Not when you lay out the sun's cycle, our blind spots, our growing technological footprint, and the precise year an interstellar visitor glides toward Jupiter. Carl Sagan once said, "Coincidence is common, patterns are rare." And the more you look at the timing of Atlas, the more it feels like a pattern gently forming in the background. Not a warning, not a signal, just a rhythm. The kind of rhythm the universe sometimes hides inside coincidence, soft enough that only those paying attention ever notice it. You picture the timeline again. A solar maximum that muffles our instruments. A conjunction that blinds us for a month. An era where humanity becomes loud and visible. A visitor that changes course exactly when we can't see it. A trajectory leading not to Earth, but toward Jupiter. Is it coincidence? Is it design? Is it drift? Is it something quietly intentional? You don't need an answer. The beauty of the question is enough. The idea settles into your mind like a feather drifting downward. Slow, gentle, calm. Timing doesn't have to mean purpose. It can simply mean alignment. A moment where multiple cosmic events overlap naturally, producing something that feels meaningful because it is rare. Visitors don't usually arrive at the perfect moment unless timing matters. You exhale, easing deeper into the softness around you. The mystery isn't loud. It doesn't demand urgency. It simply invites you to wonder about the way things line up sometimes, the way cycles overlap, the way the universe can feel coordinated even when nothing is touching. And if timing matters, then destination matters even more. In war, the high ground decides everything. The army that stands on the hill sees farther, moves faster, chooses the moment, and shapes the field. The same principle holds in space, but the hills aren't made of rock or soil. They're made of gravity, invisible slopes, deep basins, curving valleys in the fabric of space-time. And in our solar system, the highest ground of all belongs to Jupiter. Its mass is so large, so overwhelming, that space bends steeply around it. Jupiter creates the deepest gravitational well outside the Sun itself, a feature so commanding that thousands of asteroids, rocks, and fragments fall into stable orbits around it, like leaves accumulating in a swirling eddy. Its hill sphere, the region where its pull challenges the Sun's, spans more than 50 million kilometers. That's not just a territory, that's a fortress. If gravity is a landscape, Jupiter is the tallest hill. From such a hill, you can do remarkable things. Imagine approaching Jupiter slowly. You don't need rockets. You don't need fuel. All you need is a direction, and gravity does the rest. A small object slipping into Jupiter's influence can be slingshotted, flung outward, with a new burst of speed. One clean pass around the giant can send it toward Earth. Another angle can send it toward Mars. Another can push it toward the Kuiper Belt, or even out of the solar system entirely. From Jupiter's hill, every world becomes downhill. For any probe, natural or artificial, this is the ultimate energy-saving trick. A small craft could dip into Jupiter's gravity well and be accelerated toward almost any destination, gaining speed for free. The entire solar system becomes reachable with a few carefully timed arcs. And then there are the Trojans, Jupiter's two great swarms of asteroids that drift at its leading and trailing Lagrange points, L4 and L5. These aren't small groups. They contain tens of thousands of objects, many of them kilometers wide, stable for billions of years. Think of them as floating archipelagos suspended along Jupiter's orbit. Perfect cover, perfect anonymity. A small probe could hide inside one of those swarms and watch everything. It wouldn't need to be large. It wouldn't need to be loud. It wouldn't need to be fast. Just present. A quiet presence sitting among the Trojans could observe Earth, Mars, the outer planets, and even incoming visitors, all from a position no one monitors constantly. Every motion of the inner solar system would be visible from that vantage point. And from the gravitational high ground, any move could be made with minimal effort. This isn't science fiction. This is basic orbital mechanics. And that brings you back to Atlas and where it's going. Because the trajectory doesn't point toward Earth. It doesn't point toward Mars. It doesn't even target Jupiter's moons directly. It aims for the edge of Jupiter's hill sphere, the ridge line of the highest gravity hill in our planetary system. It's like watching someone walk up a mountain, not because they want the mountain, but because the view from the top changes everything. You aren't imagining invasion. There's nothing about this that feels threatening. This is strategy in the simplest sense, the kind of strategy any advanced explorer might use, or any natural traveler might accidentally follow. the kind that takes advantage of gravity's free mechanics. Neil deGrasse Tyson once said, "Gravity is the oldest form of strategy." He meant it jokingly, but the truth behind it is profound. Every motion in space is shaped by gravity. Every opportunity is defined by it. And any object that moves cleanly toward Jupiter's domain is, intentionally or not, stepping onto the highest vantage point the solar system offers. So you picture Atlas's clean line once again, that strange trajectory that threads a needle and glides toward the giant's invisible border. Not crashing, not diving, just approaching the ridge of the gravity hill like a careful climber. A natural traveler could end up there by coincidence. A guided traveler might end up there by design. Both ideas remain calm. Both ideas remain beautiful. And while this isn't a story about conflict or conquest, it is a story about position, about advantage, about how a single point in space can tell you almost everything about the motions of planets, moons, and civilization itself. If something wanted to watch us for a long time, quietly and without disturbance, Jupiter would be the perfect perch. And Atlas is climbing straight toward it. You let that image stay with you. Steady, calm, and strangely elegant. This isn't a tale of fear. It's a tale of perspective. The universe has hills and valleys, and Jupiter is the summit from which everything else becomes clear. And where strategy appears, stories soon follow. When data goes quiet, the human mind gets loud. It has always been that way. When silence grows, stories grow with it. And with 3i Atlas, that silence wasn't just a moment. It was a long stretch of time where the universe stopped speaking and left us alone with our imagination. For 45 days, we had no new measurements, no fresh images, no radar returns, no trajectory updates. It wasn't anyone's fault. It wasn't a cover-up. It was simply physics. Atlas slipped behind the sun in a solar conjunction, a position where telescopes on Earth are blinded by the sun's glare. Even the best observatories can't stare through the star that keeps us alive. And this conjunction happened during a solar maximum, when storms of charged particles and radio noise made radar nearly useless. For a month and a half, everything we had to watch the visitor went dark. That silence created the perfect environment for speculation. And speculation, in turn, created noise. Rumors began to circulate, some gentle, some wild, some strangely poetic. One said that astronomers detected exotic metals in Atlas's tail, as if shards of an advanced alloy were dissolving into sunlight. Another claimed a metallic object had been spotted near Jupiter's L4 point, drifting among the Trojans. A third suggested NASA had quietly updated the trajectory and not told the public. And the most dramatic rumor of all whispered that Juno had seen something, a flash, a shape, a shadow, and hadn't released the data. Why do these stories spread so easily? Because they sit perfectly inside the shape of the mystery. Atlas truly does have a strange path. It truly did shift course during the blackout. It truly is moving toward a region of space that seems too precise, too strategic, too clean to ignore. And when something real feels unusual, our minds start connecting dots that may or may not exist. Humans don't like empty spaces. We fill them. We paint meaning onto silence. We turn uncertainty into narrative. And this is where the tone must soften. Most conspiracy theories begin with a real question. a reasonable one. Why did Atlas drift? Why did the push happen during the blackout? Why Jupiter? Why the timing? These are good questions, scientific questions. They're the kind that keep astronomers awake at night for the right reasons. But other questions drift into territory without evidence. NASA is hiding the truth. Atlas is a weapon. A probe is already in our system watching us. These statements don't come from data. They come from fear, from imagination, or sometimes just from the human desire for a world that feels more dramatic and meaningful. And here is where science does its real work. Science doesn't dismiss mystery. Science doesn't call curiosity foolish. Science simply asks for evidence. Carl Sagan said it best: extraordinary claims require extraordinary evidence. And right now, we have no extraordinary evidence, only extraordinary silence. A silence caused not by secrecy, but by the limitations of our vantage point. Our telescopes cannot see behind the sun. Our radar cannot push through magnetic storms. Our spacecraft are few and far between. The universe is enormous, and our tools, though incredible, are still fragile compared to the scale of the sky. And so, the rumors grow, and the silence deepens, and the truth sits somewhere in between, waiting. But even as we explore the noise around Atlas, the tone stays soft. Nothing about this visitor suggests danger. Nothing suggests hostility. Atlas moves slowly, quietly, predictably. It poses no threat to Earth, no sign of acceleration toward us, no radiation, no signals, no sharp deviations. Whatever Atlas is, natural, engineered, ancient, drifting, it is peaceful. And with that calm understanding, you let the noise fade a little. The conspiracies become background static. The counter-conspiracies become gentle reminders that the truth is simpler than the stories we weave. What remains is curiosity, a quiet, steady curiosity. The kind that doesn't frighten you, but invites you to breathe deeper and wonder. Because when we zoom out, Atlas is not alone in being strange. It's part of a larger pattern, a wider tapestry of interstellar objects, odd trajectories, and cosmic travelers that have wandered through our solar system before and will wander through it again. And Atlas is just one chapter in a much larger cosmic story. Atlas feels strange, but it isn't alone. To understand it, you have to zoom out, far beyond its long tail, beyond its precise drift toward Jupiter, beyond the month it spent hidden behind the sun. Because the truth is simple, the universe has sent visitors before. Atlas is not an isolated mystery. It's part of a pattern, soft and subtle, that has been unfolding for years. The first visitor arrived in 2017. 1I Oumuamua, the first one. It flashed through our solar system without warning, fast as a stone skipping across a pond. But it wasn't like anything we had seen before. It had no tail, no glowing coma, no dust, nothing that behaved like a typical comet. And as it drifted away from the sun, it sped up, ever so slightly, with no visible source of thrust. That single detail changed astronomy. A non-gravitational acceleration with no outgassing at all. Then there was its shape, elongated, tumbling, reflecting light in a pattern that didn't match ordinary rock. And so the theories grew. Maybe it was a solar sail. Maybe it was a shard of an alien machine. Maybe it was something even stranger. The second visitor came in 2019. 2I Borisov, the almost normal one. At first glance, it seemed like the antidote to Oumuamua. A classic comet, a bright coma, a beautiful tail, gas jets, dust grains, everything we expect. But the more scientists studied it, the more unusual it became. Its structure was too clean, grains finer than typical comets, almost like a laboratory sample, and its velocity coming into the solar system was higher than expected for a random wanderer. It was normal, yes, but too perfect a version of normal. And now, the third visitor, 3I Atlas, the hybrid. Part comet, part question mark. It has a tail, a coma, and dust, all the natural features. And yet, its acceleration is clean and directed. Its trajectory bends toward a region of space with eerie precision. Its course shifts when we cannot see it, and its reappearance reveals a drift too intentional to dismiss. It looks like a comet, but it behaves like something designed. 3 visitors, 3 personalities, 3 different flavors of strange. One that breaks the rules, one that plays by the rules too perfectly, one that blends the rules together. Patterns don't appear instantly, they appear gradually. If you lay these 3 objects side by side, not in space, but in your imagination, a picture begins to emerge. A picture that is calm, not dramatic, soft, not alarming, but unmistakably intriguing. This is where some scientists introduce what they call the interstellar Gardner hypothesis. It suggests that advanced civilizations, if they exist, might send millions of tiny probes into the galaxy the way a gardener scatters seeds, not to communicate, not to conquer, but to study, to observe, to catalog worlds the way botanists catalog species. Most probes would drift forever. Some would pass through star systems without stopping. A few might linger, slow down, or approach regions of interest. And fewer still might look for high ground. Places like Jupiter. Not because of malice, but because of curiosity. You picture it gently. Tiny machines sleeping for millennia, waking briefly as they drift near a star, tasting the light, sampling the chemistry, watching worlds grow. A cosmic version of ecology. And suddenly, Oumuamua makes more sense, and Borisov makes more sense. An Atlas, moving cleanly toward Jupiter's gravity summit, becomes part of a larger mosaic. If intelligence exists elsewhere, you think, wouldn't curiosity be universal? That question hangs softly in the air, like dust suspended in a beam of sunlight. You're not imagining alien ships. You're imagining something simpler, older, quieter. The possibility that the universe has been exploring itself long before we learned how to lift telescopes into orbit. And when you reconnect this idea back to Jupiter, the pieces align even more. If you were a silent visitor looking for a stable, long-term perch, a place to observe without disturbing anything, Jupiter's hill sphere, or even its Trojan swarms, would be the perfect destination. Not Earth, not Mars, not the Sun, but the quiet giant on the outer edge of the inner system. And as you drift deeper into that idea, another connection surfaces gently. Because while we watch interstellar visitors pass through our skies, we also watch distant worlds. Worlds with their own mysteries, their own moons, their own atmospheres. And 2025 gave us one discovery we never expected. Somewhere far beyond our sun, a moon was caught breathing. Not loudly, not dramatically, just a faint exhale written in starlight. A whisper revealed in the quiet language of light passing through air. Astronomers watched a distant star dim for a moment as a world crossed in front of it. But this time, the dip in brightness carried something extra. As the star's rays filtered through the thin layer surrounding that moon, they picked up chemical signatures, the spectral fingerprints of an atmosphere. Transit spectroscopy sounds complicated, but the idea is beautifully simple. When a moon glides across its star, the starlight must pass through whatever surrounds it. If there is air, that air absorbs certain wavelengths and lets others pass. Instruments on Earth read those gaps in the light, like scanning the barcode of an entire world. It's gentle work, soft, like reading the memory of a place through the color of its glow. And for the first time in human history, that reading revealed the breadth of an exomoon, not a planet, not a giant world of storms and oceans, but a moon, a smaller companion drifting quietly around a distant giant. Suddenly, moons are no longer the supporting actors of the cosmos. They are worlds in their own right, with their own skies, their own chemistry, maybe even their own stories. And naturally, your mind returns to Jupiter, because our own system holds more than 79 moons orbiting that vast world, each one different, each one carrying the potential for complexity. Europa, with its global ocean beneath cracked ice. Ganymede, the only moon with its own magnetic field. Callisto, ancient and untouched, hiding secrets frozen for billions of years. These are not barren rocks. They are archives, laboratories, sanctuaries, places where something could hide, places where something could last. If an interstellar probe drifted toward Jupiter and wanted a quiet home, a perch to observe, or to rest, or simply to endure, a moon would be the perfect choice. Protected by the giant's magnetosphere, fed by gentle light, covered in ice or rock or thin air, a refuge in the shadow of a colossus. And suddenly, the discovery of an exomoon atmosphere far away becomes more than an isolated finding. It becomes a mirror, a reminder that moons everywhere are more than ornaments. They are potential homes, potential archives, potential destinations. What we learn from faraway moons helps us understand the ones near us. And what holds true for distant systems can hold true for ours as well. You picture it softly, worlds upon worlds, quietly orbiting their giants, each one carrying the faintest breath of possibility. Atmospheres do not guarantee life. They do not guarantee oceans or biology or anything grand, but they do guarantee chemistry. And chemistry, in the quiet logic of the universe, is the first doorway to complexity. A moon with air is not just a moon. It is a canvas. And the more canvases we discover, near or far, the more we understand the environments where life might emerge, where probes might linger, where civilizations might explore, where curiosity might land. This new exomoon, breathing softly in starlight, reminds us that the universe doesn't just build planets. It builds systems, layered, rich, intricate. It builds opportunities, and it prepares you gently for the idea to come. Because if a world can remember its past through the chemistry in its atmosphere, then a ship, drifting for thousands of years across interstellar space, may remember its journey through something far stranger. Memory is not limited to biology. It can exist in fields, in particles, in the quantum fabric of reality itself. And the universe just gave us a breakthrough. But even the most patient traveler needs memory, and the universe just gave us a breakthrough. Fan 12, Quantum Memory, Brains that Outlive Their Makers, 850 words. Imagine a mind that sleeps for 1,000 years, then wakes with perfect clarity. No confusion, no decay, no forgetting, just a quiet return to awareness, as if only a moment had passed. That is the essence of quantum memory. In 2025, researchers crossed a threshold once thought unreachable, something called the quantum error floor. For decades, qubits could store information only if they were constantly corrected, constantly monitored, constantly stabilized. A single cosmic ray or temperature fluctuation could erase everything. But then came the breakthrough. Teams demonstrated qubits that could hold information far longer than before, maintaining coherence for unprecedented durations without endless correction cycles. It didn't solve every problem in quantum computing, but it solved the most fundamental one: staying alive. And suddenly, a door opened. Because interstellar travel isn't about speed, it's about survival. The distances between stars are not measured in months or years, but in centuries. A spacecraft traveling between systems cannot depend on conventional electronics. They corrode, glitch, degrade, freeze, or burn out under cosmic radiation. But a memory system based on quantum states, stable across ages, could endure the vacuum. It could sleep through the journey. It could awaken when needed. It could remember perfectly. This is where the mind drifts naturally back to the idea of Atlas. If, and only if, Atlas were a mothership or a probe launched by some ancient civilization, it would require exactly this kind of memory, a system that could drift for thousands of years without losing its identity or its purpose. A system that could wake during solar encounters, adjust course, store data, and return to rest. A mind in hibernation. You imagine such a thing not as a machine humming loudly in the dark, but as something quieter. A lantern that glows only when needed, conserving its light for centuries at a time. A presence that doesn't rush, doesn't tire, doesn't age the way we do. Something built for the scale of the galaxy. This visualization softens the idea. It becomes less like science fiction and more like a natural extension of physics. Quantum coherence sounds intimidating, but the concept is gentle when you strip it down. A quantum state is delicate yet resilient. It can hold a pattern, a piece of information, with remarkable stability when isolated from its environment. And as researchers learned how to shield those states more effectively, the possibilities expanded. If qubits can survive long enough inside a laboratory, then in theory, they could survive in a well-designed craft, insulated from radiation, cooled by starlight, preserved in near-perfect vacuum. And because quantum memory requires no constant power, it can rest peacefully for ages. It's not proof, not evidence, not a declaration. It's simply a reminder. The things we once believed impossible are inching closer to possible. And if we, in our early technological century, are beginning to touch quantum longevity, then a civilization older than ours, even by a few thousand years, could have mastered it entirely. A probe launched long before our species existed could still be mentally intact today, drifting through space the way a leaf drifts across a lake. A curious presence, not malicious, not urgent, just patient. Longevity is the real frontier of intelligence. David Deutsch once said that, and the idea echoes now. A mind is only as capable as the time it can endure. A civilization that understands this would build machines that don't think quickly, but think slowly. over centuries. Machines that don't panic, don't decay, don't forget their mission. Machines that can cross the galaxy not with speed, but with persistence. And suddenly, Atlas's slow glide, its quiet adjustments, its unhurried precision begin to feel different. Not threatening, not dramatic, just timeless. The kind of motion you'd expect from something that remembers where it came from and where it's going. But even the most patient traveler needs more than memory. It needs a map, a way to navigate not just through stars and planets, but through something far stranger, the invisible scaffolding that shapes the universe itself. And that brings us to the next piece of the puzzle. If you could see gravity, you would see a landscape wider than light. A terrain woven into the fabric of space. Ridges, valleys, gentle slopes, and deep invisible basins that stretch across the galaxy. We think of space as empty, but it isn't. It has structure, contours, highways, invisible architecture shaped by dark matter. And for the first time, in 2025, humanity managed to glimpse that hidden landscape. The breakthrough came from something called pulsar timing arrays, a network of cosmic clocks sprinkled across the Milky Way. Pulsars are neutron stars that spin with incredible consistency, firing beams of radio waves that sweep past Earth like the tick of an atomic clock in space. Their rhythm is so precise that even the slightest disturbance, a gravitational ripple, a subtle curvature in space-time, changes the timing by billionths of a second. Astronomers began comparing these tiny timing shifts across dozens of pulsars. When the ticks didn't match what they predicted, they traced the distortion back to its source. Dark matter structures bending space in ways we could finally measure. The result was astonishing. For the first time in human history, we created a three-dimensional map of dark matter gradients, the slopes and contours of invisible gravity shaping our galaxy. It wasn't a map of stars. It wasn't a map of light. It was a map of the unseen, a map of the universe's skeleton. And here's where the idea unfolds gently. This map isn't just beautiful, it's useful. More useful to a civilization advanced enough to cross the stars than any chart of constellations or nebulae. Because interstellar ships cannot travel in straight lines. They move through a cosmic ocean of gravitational pulls, stars tugging, planets bending, dark matter shaping the void. A ship trying to go directly from one star to another would constantly be nudged off course, like a boat drifting sideways in a cross-current. But if you knew the shape of the dark matter landscape, you could do something extraordinary. You could surf gravity. You could follow the easiest slopes, avoid the steepest wells, and ride the smoothest gradients. You could cross hundreds of light years with minimal energy. The way ancient sailors once crossed oceans by reading the winds and tides instead of fighting them. Imagine sailing through an ocean whose waves you cannot see, but can feel. That is what navigating by dark matter would be like. And suddenly, Atlas's path, its smoothness, its precision, its lack of chaotic drift, becomes easier to understand. If Atlas were simply natural, it has behaved unusually well. If Atlas were engineered long ago, drifting silently across interstellar space, it might have been programmed with something like this: a gravitational map, encoded not in starlight, but in the invisible structure of the universe itself. It wouldn't need fuel. It wouldn't need constant corrections. It would only need to follow the contours. The way a leaf doesn't choose the river, it simply follows the current. And the more you consider this, the more soothing it becomes. Not dramatic, not alarming, just logical. If humanity is beginning to read dark matter gradients now, in our first technological century, what could a civilization 1,000 years older do? Or 10,000? Or 1,000,000? They wouldn't navigate by light. Light flickers, bends, hides behind dust. Gravity does not. We navigate by light, you reflect softly. A more ancient intelligence might navigate by gravity. And as the thought drifts through you, a quiet sense of awe settles in. Not the explosive awe of discovery, but the calm awe of understanding. The feeling that the universe is not chaotic. It has patterns, rules, a hidden geometry we're only beginning to learn. A geometry a traveler like Atlas might already know. And now, with this final piece in place, quantum memory for longevity, dark matter gradients for navigation, Jupiter as the gravity high ground, the story of Atlas shifts into something gentler, something quieter, something that feels less like a warning and more like a whisper from the cosmos. The universe is vast, it is ancient, it is structured, and you are safe within it. And now, with Atlas drifting toward Jupiter, we return to your quiet world. Out there in the dark, 3i Atlas is only a speck now, a soft glimmer slipping past Jupiter's vast domain, its long dust tail fading like cold breath, disappearing into the night. It moves without urgency, without noise, without any sign that it seeks attention. Just a quiet traveler, continuing its path through the deep. And here you are, watching from a warm corner of a small blue world, listening, wondering, breathing slowly. Tonight, we walked through the long, delicate chain of events that brought Atlas to our attention. A shift in its path, hidden behind the sun, a trajectory too clean to ignore, a brush with Jupiter's invisible threshold, Juno waiting as our only witness. The possibility, gentle, never loud, that Atlas could be more than it seems. The timing of its arrival, the gravity high ground, the other strange visitors who came before it, moons that breathe, minds that sleep for centuries, maps made of dark matter guiding travelers across the galaxy. Piece by piece, a tapestry formed, not frightening, not certain, but quietly astonishing. And now, at the end of this journey, you can let that tapestry settle. There is no claim here, no conclusion, nothing proven, nothing dismissed. Atlas does not show signs of danger. It does not change anything about tomorrow. It does not point itself toward Earth. It simply glides on, following a line that is remarkable only because it is precise. Terrifying, not because it threatens us. Terrifying because the universe can be this exact. Because something natural shouldn't hit a 1 in 26,000 corridor. Because a drift in darkness shouldn't line up with a gravity keyhole. Because silence shouldn't carry so many possibilities. And yet, it does. The beauty of the unknown is that it asks nothing from you. It just offers a question, a gentle one, a question shaped like wonder, not fear. Tonight, nothing changes for you. The moon will still rise at its usual hour, glowing with the same familiar calm. Earth will continue its soft rotation under your feet. Your neighborhood will stay quiet. Your pillow will still remember the shape of your head. And the sky, vast and ancient, will stretch above you just as it always has. You are safe. You can breathe a little slower now. Let your shoulders soften. Let your thoughts drift the way Atlas drifts. Not searching, not pushing, just floating. If there is one thing humanity excels at, one gift we carry that no engine or probe or star can match, it is this. We know we are small, and we still choose to understand. We look up not because we expect answers, but because the questions are beautiful on their own. Whatever Atlas is, it will still be there tomorrow, and the day after, and the day after that. It doesn't demand anything from you. It doesn't ask you to solve it. It doesn't hurry you toward conclusions. The universe never does. It invites you, quietly, to wonder at your own pace, to be curious without needing closure, to rest in the mystery the way you rest under a blanket, warm, safe, held. You can picture the solar wind whispering past Atlas now. Picture Jupiter rotating in slow, regal silence. Picture Earth glowing softly in the distance, wrapped in its thin blue atmosphere. Picture yourself, breathing gently, part of this enormous, patient cosmos. Carl Sagan once wrote, "We are a way for the cosmos to know itself." And tonight, by being here, listening, imagining, feeling that mix of curiosity and calm, you are living that truth in the quietest, most human way. Let the universe be vast. Let it be mysterious. Let it be larger than you can grasp. You don't need to hold it all. You just need to rest beneath it. For now, just breathe. Let your thoughts fall away like dust drifting from a comet's tail. Let the darkness feel soft. Let the night feel still. You've traveled far enough for one evening. Rest. Sleep deeply. And drift. Just a little. The way Atlas drifts. Peacefully. Softly. Without fear. Good night, traveler.